Here we have a typical question that can show off regarding fundamental theorem of calculus. It's got two parts. The second part deals with taking the antiderivative, and then the second f subtracted by the first f. But the first part is finding the derivative. So when you have this expression, that means we are to find the derivative of this function all in terms of variable x. So that's all we are interested in. But if you look at the right expression, they are using variable t. They've sort of borrowed it, but it's going from 4 to x. So if we were to take the antiderivative of this expression, we will have this notation with that subtracted by f at 4, given that f at x is the antiderivative version of this. So this is what fundamental theorem of calculus is about. So here, this is saying that, well, in this case, it should be capital F because that's what this is. Here we are saying that f at x, that they are the same, basically the antiderivative. So taking the derivative of this, because we are doing it in terms of variable x, this is a constant factor. Instead of x, we've got a numeric value of 4. This is the lower starting point of the integrand. So this is a constant value, as in this is going to be some kind of a number. So if you were to take derivative of this expression, then this term will just completely disappear because any constant number becomes 0 when we take derivative. So we will only be left with this. But knowing that its derivative form is already here, then we can use that. That's what this question is all about. So from here, we can proceed. So first, this means we want to find df in terms of dx. You want to think of chain rule, because everything is in terms of t now. So you can borrow that t for a time being, but ultimately take derivative with respect to x. So here we can just take this expression, but instead of t, we can plug in this value. So this will equal to tangent squared of root x, but we also need to multiply by this thing because ultimately we want to have the derivative of the function in terms of variable x. So if we were to take derivative of this, because these are the integrand, when it says integrand, they are the values that the variable t goes over. So it's saying that t is going from 4 to x. So these values, these numbers are represented by the variable t. So t goes from here to here. So now we need to take derivative of that when it comes to the first term. So we'll be multiplying by 1 over 2 times square root derivative is 1 over 2 comes down because square root x is equal to x to the power of 1 over 2. Taking derivative 1 over 2 comes to the front. You subtract by 1. This becomes 1 over 2 x to the power of negative 1 over 2. When you have negative, that means bring it down, reciprocal function. So this then becomes 1 over 2 root x. So we've got that and then 1 over x. So we can just simplify this as tangent squared of root x over 2 root x. So when you are given integral expression where one end, or it could be both some cases, then you need to write out this expression. You need to take derivative of the first one as well as the second one with whatever expression that are given to you at the end of the interval, which is here and here. So you need to multiply by this, borrowing the chain rule concept. So you can plug in these points, but you need to also multiply by the rate of change for this variable t in terms of x.